Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be looking at angles formed by lines, and we're going to start off with the linear pair. A linear pair are two adjacent angles that have non-common sides that form a straight line, and in general this means that a linear pair sums to two right angles. In the degree system, a linear pair sums to 180 degrees. See, here we have an example of a linear pair, and this kind of represents our basic linear pair calculation problem in which one angle is known and the other is unknown. So what we do is we set up a linear pair equation. This is the angle addition postulate. Actually, it's CAB plus CAD equals the straight angle DAB. We just don't write down the angle DAB. We know its measure is 180. We substitute and subtract to find out that angle CAD is equal to 128 degrees. In class we're going to go over a couple of these, but again it's the same process: angle addition postulate to set up the equation, make a substitution, and then subtract for your answer. Our next group is about vertical angles, and vertical angles are created when two lines intersect. They share a vertex but no other common points. For example, here CAB and DAE are vertical angles. DAC and EAB are vertical angles because they share the point A but nothing else, and they're formed by intersecting lines. One of the interesting properties of vertical angles is that if we kind of roll around the intersection, you see that we have a linear pair here on top between CAB and DAC, which means we can compute the measure of this angle. 180 minus 79 is 101 degrees. And then another linear pair here between CAD and DAE. This would be 79 because 180 minus 101 is 79. And then over here BAE is a linear pair with DAE and also CAB, and its measure is also 101 degrees. So you see that the measures of vertical angles are equal to one another. In class tomorrow, we are going to, tomorrow actually, I guess it would be today, we're going to prove that a linear pair sums to two right angles, and the process is essentially the same thing we've looked at before, and we'll look at that tomorrow. We'll also prove that vertical angles are congruent. You do this by subtracting linear pair equations and have common angles that dropped out, and again we'll look at this tomorrow as well. I'd like to a couple words about the independent practice here. Notice that the angles are equations. What this is going to allow us to do is set up one of two kinds of equations. If we're looking at vertical angles, we set them equal and solve for x. If we're looking at a linear pair, we set them equal to 180 and solve for x. So for example, we start off by claiming that the angles are equal. So here angle ABC is equal to angle DBE because they're vertical angles. And then by substitution we can say that 5x plus 10 is equal to 10x minus 50. And of course then we can solve for x. Here we have a linear pair, and we use the angle addition postulate to set up angle BCD plus angle DCA equals 180. Alright, again 180 is representative of angle ACB. It's a straight angle, so its measure is 180. Then by substitution we'll say 3x plus 38 plus 15x minus 8 equals 180. The parentheses are not necessary, but I like to use them when I'm doing substitutions on the same side of an equation so that we can see where things came from. So like this is together angle BCD, this together angle DCA, and of course we can solve for x from here. And that about wraps it up. So see you in class tomorrow.